Hello, testing, recording Unit 3 for Java. And hello. Looking at my desktop right now, getting set up here a little bit yet. Okay. So at this point, we're looking at Chapter 3 in the textbook. And before you spend a lot of time with my lecture, you should read the chapter, and you should watch all the web companion videos offered for this chapter. And as you're watching these web companion videos, the author is lecturing or dissecting code as I do or would if we were in the classroom. So along with watching these videos, you can copy and paste the sample code for each figure in the textbook from your C:\examples to your project name folder in the NetBeans folder. And we've been kind of setting that up at C:\Java, our homework. So copy each shared sample code to your C:\Java homework and the folder name for the project that you're working on. Copy that into the source folder, and then in NetBeans you can go ahead and execute. And I'll show you another example of setting that all up when we dissect our code for this chapter. Now I'm going to lecture dissect actually figure 3.8 and figure 3.9 on page 85 and 87. And then our code discussion in the narrative is from page 85 and beyond. So since I know that I want to be working with the sample code examples, I'm going to set up my project in NetBeans and copy the sample code to my project. So let's go ahead and do that. So I'm going to start NetBeans. Starting NetBeans. And I want to set it up for a new project, so I'm going to close the start page. File, New Project. I want Java selected and Java application. Kind of depends on who may have been using the software prior to you. Choose Next. And then our project name. Usually try to find something meaningful. I'm going to call my project figure 03 underscore 08 underscore 09. Just remembering that we can't use the period or the dots character in our file names or folder names other than the dot extension. My project location is C:\Java homework, which we've already set up. And I want to make sure that since I'm going to be creating my own code, or in this example, I'm copying existing code, I do not need the system to create a main class for me, so I'm going to deselect that option. Make sure you deselect that option for your own code purposes, and then finish. And now I'm going to open my Project Explorer view. I have a project name. Expand that, and I have my source packages and my libraries. So I'm going to minimize here, go to Explorer, and from my C drive, I want to make use of my sample shared codes from the author. So I'm going to go to my examples folder, and I want my chapter 3 files, and I'm looking at the figure 03080-9 figure 03 underscore 08-09 as shared by the author. Open that, and there's my two files, figure 8 and figure 9. I'm going to click to select those, right click to copy, and minimize. Back at Explorer, I go to my C drive again, and I'm looking for my Java homework folder, and my figure 03 underscore 08 underscore 09 project folder. Open that. Open the source src folder where I want to right click and paste my shared files, account.java and account test.java. So now I have done my file maintenance and organized my files so that they are in the working folder path in the project folder under the source code area. We can close. Go back to NetBeans. And now with your Project Explorer window open, expand your source packages. Expand by clicking on the plus, expand the default package, and there we see our two support example files. So I'm just going to double click to open account, and now my tab shows in my working window that account.java is being listed, and we see the opening beginning documentation. You could now edit, revise, change, save it again, and kind of test. Well, what if I do this, or what if I do that? But we didn't have to type all of the shared code, so that's always helpful. Beginning documentation, remember in your project program assignments, the beginning documentation is required, and that is highlighted at D2L. Beginning documentation with the //. Comments can be beginning, and comments that accent or highlight certain activity. Maybe to define some interesting code. So always document with beginning required documentation and internal documentation. And I wanted to mention that we also have our account test.java. So let's double click to open that. And now I have the two tabs with account test.java current, and you can go back and forth between the two files. Now the naming scheme that our author is using is the class name.java. Account is the class name at this point, and account test to complement the file that provides the code that defines the class object itself. The account test is actually the program that is the driver program. It drives the execution, interaction, and calculations using the account objects. So the scheme is classname.java with all the properties and methods, constructors of the class, and then the account test as a file name, which could just as well be account driver.java or account run.java, account execute.java. So just so you know, different authors might use different schemes, and our author is just being rather consistent at this point in a file naming scheme. And so you can follow that same file naming scheme to associate the files, the class file and its testing file or its driver file for file naming. Okay, so we have our support source code files within our project. So now we're ready to run. I'm going to choose the run green arrow to execute. You may get a prompt at times. Select the file name that has your main class driver statement in it. And of course, here's our public static void main within our account test.java. So we are correctly set up. If there's options, you need to select the correct file that has the public static void main statement. So we're running, and now the output window displays, and we have Jane Green balance $50 and John Blue, and on a new line, John Blue balance space and $0.00 formatted. Enter deposit amount for account 1. Okay, so account 1 is our Jane Green. And I'll just follow the textbook. At the keyboard, I'm going to enter 25.53 and enter. And now your program is executing and adding 25.53 to the current account balance. So, and then displaying the account's current balance. So Jane Green's current balance now is 75.33. And John Blue's current balance has not changed. And then we're prompted to enter a deposit amount for account 2. I'm going to enter 123.45. And now we're in the process of adding $103.45 to account 2's balance. So Jane Green's balance remained the same, but we interacted with the account 2 object and added to its current balance $123.45. So that looks pretty good with the information that I see on my output screen. But looking at my code, I see that the account object, account named account2, is equal to new account, and I'm sending a string, John Blue, and a negative value, negative 7.53 for a current balance. So I'm instantiating a new account object named account2, and in its constructor I'm sending or passing a string parameter and double amount. So let's look at our account itself. Now account, the object has the two private variables, a string variable name and a double balance, and the constructor expects a string to be passed along with a double balance value. We're doing that. A negative number is a double value. This .name is equal to the name string that we passed, and then validate that the balance is greater than 0. If it's not, instance variable balance keeps its default value of 0, 0. So as I'm constructing or executing and instantiating a new account balance in primary memory, if the balance is greater than or equal to 0, this account 2 balance will be equal to the balance that we passed. However, if it's not, then the constructor will automatically initialize the parameter balance to 0. Since it's a double value or an integer value, the default instantiation of the instance variable would be 0. So by default, balance is set to 0. In my constructor, I test if balance is greater than or equal to 0. I'm able to go ahead and assign it a value. If not, it's by default within the constructor initialized to a starting value of 0. Well, that's about all I want to say right now regarding logic and code. I'd like to go back to dissecting the code. So let's begin by designing this program from scratch. So to design, I want to make use of my universal modeling language. And you'll see discussions of that now beginning in chapter 3. And I'm kind of spinning off the trailing discussion, you might say, on page 89 as I'm doing the class diagram for our account object. So we know that we're going to be building our table. In the first compartment, we center and bold the name of the class itself, so that's a little heavier, bold. And we're going to model our account class object. Our second compartment, names the variables that the account maintains, and our private, use the hyphen, instance variables for this account object. We have name and colon, its data type. And we also have a private balance variable, and its data type is double. Now, as we're kind of designing this in the design phase, we're documenting in a way that we can pick up and write directly from this code. That's the private instance variables of this account. In the third compartment, and you've read about this, and there's a couple other examples in chapter 3 as well. We depict in the UML language, you might have heard pseudocode. Pseudocode is more of a quasi-written, kind of a narrative code maintaining the logic of your program, but in a way that many more people might understand the logic of your program rather than simply programmers who understand the logic and the specific language code that you're designing in. This is kind of a universal modeling language, so many people can follow this logic, and then taking this logic and its style, kind of its format, can begin to design their code in multiple or different languages with the syntax of the particular language. So we want to itemize first the constructor or constructors within your class object. And so we highlight that this is a constructor with our guillemets, those symbols, which are greater than, and less than indicators. And then the name of your constructor, which is the name of the class itself, and its parameters. And we have a name and its data type, comma, and we have balance as an instance variable and its data type. And we continue then in the third compartment with any methods that this account maintains. Now, the plus symbol is used to indicate that it's a public method, and our first method is deposit. And I chose that for a name. As I'm designing, actually we inherited sample code, but as I'm thinking about designing my program, my object account, what are some things, what are some activities that an account would need to do? And we think about an account maintaining a balance, an account accepting a deposit, and an account being able to execute the code that would allow for a withdrawal, perhaps. So at this point, I'm going to indicate that the account will have a method. It's going to be a public method named deposit, and its parameters are deposit amount, and these are naming schemes for variables. If we're designing from scratch, we'd be designing our own variable names. It's of type double. And right now we're listing parameter and their data types for this method. So a deposit will allow for an incoming double amount to be processed. I may want some output, so I may want to get the current balance. Get the current balance, so there's no parameters there. But if I'm going to get some value, I'm going to have a return type, and that is of type double. So my get balance is going to return a value, and we indicate its data type in our universal modeling language, our format, our plan. Rather strict. We inherit some syntax rules in universal modeling language. We also have an instance variable called name. So we may want to assign that name instance variable. So we can have an account that knows how to set its own name. That method has a name parameter of data type string. And again, now we're addressing a method with a parameter list. And if we're able to set an instance variable's name value for this account, we probably want a method that provides the actions to get that name value. I should maybe make that a little closer. Remember, with methods, it's open paren, no space. And we want to indicate its return type, which will be string. So that is a return type. And at this point, that's what our account object is able to do. It maintains a private name variable, instance variable, and a private balance instance variable. It has its constructor that we send a string and a double parameter to. It's able to accept a deposit with a parameter expecting to receive a double value. We can get the current balance. It'll return a double value. We can set the name, passing a string value to that method, and we can get the name, and it will return the instance variable value currently assigned to the private instance variable name as a string. So let's look at our code again and see how close our code is to our universal modeling language. Back to NetBeans, and we have designed in the design phase what we expect our account object to do with methods and what we expect it to maintain as private instance variables. The name of our object is account, so that matches. We're going to use our public class account. We have a private string variable, and we're going to call it name. It is an instance variable. It's within the public class begin end braces. We have a private double balance, balance being the name of the variable of type double, and it's an instance variable. And sure enough, in our universal modeling language, we had in our second compartment private name of type string and private instance variable balance of type double. Now we're ready to create an instance of this object with the code for our constructor. So our constructor is going to construct or instantiate an object by the name of account. It expects a string variable to be passed to this call and a double variable value to be passed to this call. When I call the account instantiation statement from my account test, the driver, it will inherit a string and a balance. So let's take a peek at our driver program. This is the class named account test. Our public static void main is where, when we run the program, our program begins here. And now I'm instantiating an account type. It's a class object. So I'm instantiating an account object by the name of account1. That's the variable name for the first account object that I'm declaring. Using new, I'm calling account, and that's the name of the object, so it is a constructor. And I'm sending a string parameter, and I'm sending a double parameter. So my constructor is inheriting the parameter value of Jane Green, and it's inheriting a balance as a parameter of $50. Let's see what that looks like. Now I'm sketching a visual. This is from line 9 of account test.java. In line 9, we are executing a new account object by the name of account 1, and it's equal to, and now I'm instantiating a new account object in primary memory. And I'm sending a string and a double to the constructor in account.java. So now my instance variable, private instance variable of name and private instance variable of balance are being assigned. And that looks like, and I just kind of draw or sketch, this is primary memory now, and somewhere in primary memory being maintained with a variable name of name is Jane Doe, or Jane Green. And this object is being maintained as an entire account object with a private instance variable of balance. And its current amount is 50 as a double, stored and maintained as a double. And the name of this account object is the reference account 1. back to my driver program. The next line, line 10, I'm instantiating a new account object by the name of account 2. I'm calling the new account constructor. I'm sending a string and a double amount. So the account call comes to the account constructor, new account, call the method account. So back in account, I'm executing the public account constructor method, and I'm inheriting John Blue as a string assigned to name, and I'm passing a double value of balance, negative 7.53. This dot name, this account is account 2. So from line 10, I'm instantiating a new account object by the name of account 2. It is a new account, so I'm calling the method account, which is the constructor, and I'm sending John Blue as a string parameter and a double of 7.53. And so in current memory, I'm taking some space to maintain the private instance variable name. And I gave this object in primary memory reference account name account 2. And now back to executing this, which is account 2's dot instance variable name is going to be equal to the name that was passed to the parameter, which is John Blue. And then we have some processing to do. If balance is greater than or equal to 0.0, well, it's not. We sent a double value of negative 7.53. And since this is not true, account 2's balance will not be assigned the balance passed. So this is false. We don't execute this, and the constructor will, by default, initialize int and double float the variables of the instance variables of this account to the default values, which is 0. So our instance variable balance for account 2 didn't pass our test. So the account constructor itself set a default value of 0.0. Remember, we use our constructors to do some of that testing to kind of air trap assignments to our instance variables. And of course, we wouldn't want our instance variable balance to be less than 0 on startup. So your constructor takes over, and your constructor will, by default, initialize all strings to null and doubles, floats, and ints to a value of 0.0. So let's go back to the program itself. We now have account 2 instantiated in current memory. So account test, we have account 1 and account 2 established in RAM. Now we're going to system.print out a balance in a formatted amount, and that's a string. So we're going to print the string balance in a formatted amount. We're going to get from account 1, get name. Well, we know how to access account 1, and we're going to use account 1's get name. So we're going to the account source code, and we want to get the name. So we're going to look at the method get name. So our public string get name is the method. These are the actions that this method knows how to do, are statements within the begin and block of this method. And this method is going to return a string value. So we're going to return name, and name has already been assigned for account 1 as the instance variable of the account. So we're going to return the string Jane Green. So we're going to print a string Jane Green balance, colon, and then a $sign, and we're going to format with 2 places following the decimal point, the next double value from account 1, which is get balance. So we're calling account 1, and we're going to use the method get balance. So back to account, we need to find the get balance method, and sure enough, here's our public get balance, and get balance is going to return a double amount, and it's actually going to return to our calling program balance, which is our private instance variable for account 1. So we're going to return $50 fit to the format string and a new line. Our next line of code, in the account test driver program, these are the actions to produce our output. We're going to have a system.out.print formatted, a string, a keyword balance, colon, the $sign, and then a double value amount fit to 2 places following the decimal point, and a new line and a new line. The first string that we're going to place in this formatted output string is account 2 dot get name. So let's find that. In the object account.java source code, we want to call the get name method, and the actions of the get name method are to return the instance variable for account 2 as a string. So we'll return as a string account 2's name, which is John Blue, space balance, colon, space $sign, and then we're going to fit our double value to a floating point of 2 places following the decimal point. The next double value is account 2. So we're going to use the object account 2, the object named account 2 dot get balance. So I go back to my account class actions, and I'm going to get to the find the code for the get balance method. The actions are between the begin and end braces of the method. It's going to return the balance for this account, and this account is account 2, and it returns that amount as a double to the calling environment, which is our driver program account test. And so we're going to print in our formatted string the double value of 0.0. 0, 2 places following a decimal point, and a new line and a new line. So let's look at our output again. I think I did run this. We have Jane Green, account 1 balance. Account 1's name is Jane Green. The balance for account 1 is $50 with our formatted string, output string. And we've printed on a new line John Blue, account 2's instance name variable value, and account 2's instance balance value of 0.0, checked with error trapping statements within our constructor. Next, within account test.java, our next code is a scanner to create input from the keyboard during execution. So we're going to capture from the keyboard some input. It'll be the next input actions at the keyboard up to the enter key. So system.out.print, we're printing a prompt to the user. Enter deposit amount for account 1. We enter some amount, and as a double, deposit amount is equal to the input of the next double offered at the keyboard by the user. Now we're expecting that the user is going to enter successfully a double interpreted value. We don't have a lot of error trapping involved here, but when you're running the program, you can just check and see what happens if you enter your name. Enter deposit amount for account name. It's expecting a double, and see what happens. We're going to, let's see, in our example, we input for account 1, and I'm on page 87. We're going to input 25.53. And that double will be assigned to deposit amount. Then system.out printf in a formatted output string. We're going to create a new line, adding space. We're going to use the next double amount formatted to 2 places following a decimal point, which is deposit amount, and deposit amount we just assigned a value of 25.53. So 25.53 will be on the output line, space to account 1 balance, new line, new line. So sure enough, we entered 25.53 at the keyboard enter key. There's a couple of new lines, and then our prompt to ourselves. On output, we are adding $25.53 to account 1 balance. And there's account 1's call. Account 1.deposit is a method, deposit open paren, and we're passing the $25.53 amount to deposit. What happens with our deposit method for the account? I'm going to have to find the deposit method. We have a call to deposit. Here's our deposit method. Public void, it doesn't return anything. Deposit, we sent a double as 25.53. The actions of deposit method, if deposit amount is greater than 0.0, well, it is. It's $25.53. our instance variable balance is increased by the deposit amount sent as a double parameter to this method. So balance is reassigned its current balance plus the new deposit amount for account 1. Back to the Java account test.java source code. System.out, we're going to print a string from account1.getName, which will be Jane Green, space balance, colon, and now we want a $sign, and we're going to print a formatted double to 2 places following the decimal point, and our double is account1.getBalance. Account1.getBalance. So back to our account object, we want to get the balance. Public double get balance, it's going to return a double value. It's going to return to the calling environment the instance variable balance. Balance was just updated for account 1, and account 1's current balance will print formatted to 2 places following the decimal point. And the new amount is $123.45. So now our account 1 object in primary memory received a deposit action which reassigned balance to its old amount, well, to its current amount plus the deposit amount, and reassigned the instance variable balance to that new amount, $123.45. So now our account 1 object in current memory is maintaining an instance variable name with the string content Jane Green and an instance variable balance of type double for $123.45. So we're ready to do the same thing for account 2. We're going to print our documentation for account 2 and account 2's balance. We're going to prompt the user to enter a deposit amount for account 2. We will call deposit amount, which is a double local variable, and it's going to be assigned to the input of the next double that the user enters at the keyboard. We're going to output in a formatted string a new line, and the string is adding the double amount of the deposit just made, offered at the keyboard by the user. And then we're going to take action to reassign account 2's deposit method with a deposit amount, and the deposit amount that we typed is $123.45. And now I need to correct my output screen here for you a minute. I turned the page too soon in my book. For account 1, we added, I can't even add, to account 1 the $50 amount plus a $25.53 deposit, and that would reassign your instance variable for account 1. If you add 50 plus 25.53, you get 75.53. have to be able to add correctly. Longhand. Now we're doing the same thing by assigning at the keyboard $123.45 as a deposit amount for account 2. The deposit amount is added to the instance variable for account 2, which is 0. And 0 plus $123 would reassign account 2's instance variable balance to $123.45. And now we're ready to output in a formatted string account 1's name with account 1's current balance, and account 2's name with account 2's current balance. Again, checking the output. Adding $123.45 to the account 2 balance. So Jane Green's balance didn't change from her last deposit, but account 2's John Blue balance did change with the increase of $123.45. So that's the walkthrough on my part of the shared code for figure 3.8 and 3.9. And I'm trying to introduce you to the narrative discussions in the book, in the textbook regarding UML, and give you a visual of kind of what's going on there as we build and design our account with the syntax of a universal modeling language. And in your textbook, that visual is on page 89. And there's quite a bit of reading and narrative to go along with that. So be sure to be reading and doing as you're working through this chapter. Now, I'm expecting that this will be the Unit 3, Part 1, if you will, lecture. And then I'll come back in a short while and do a Unit 3, Part 2 to give you some insight on how to design and write your code for your program assignment for Chapter 3. All right, thank you very much.